Hi math students! Today's lesson is going to be on multiplying and dividing integers. It's what our objective says. I can multiply and divide integers. At this point in the unit, you should have already watched 3 lessons. We had a lesson on how to multiply, a lesson on how to divide. Yesterday, we started looking at some multiplication and division word problems. We are building on all of those skills today in our 4th lesson, which is more multiplying and dividing, specifically looking at how you multiply and divide integers. Now, at this point in the class, we have seen this word before. We talked about adding and subtracting integers. Do you remember what integers are? Integers, we said, are the set of positive and negative numbers. So when we talked about how you add and subtract integers, we also, in that lesson, familiarized ourselves with what integers are. We are going back to those negative numbers again, this time to talk about multiplying and dividing. Now, one of the things I want to say at the beginning of this lesson, and I'll say again at the end of the lesson, is that adding and subtracting integers is very different than multiplying and dividing integers. There are some rules we talked about in the addition and subtraction integer lesson. You can temporarily, for the next half hour, forget those rules because with multiplying and dividing, we use a different set of rules. After this lesson, when we come back next week, the first thing we're going to look at next week is a review lesson on how you add, subtract, multiply, and divide integers all at once. So we don't permanently forget how to add and subtract integers, but do know, I do want to say at the beginning, do know that what we're doing today is different than what you've already done. So with that said, we are going to start this lesson on how you multiply integers. There are 2 rules we use for multiplying integers. The first is when you multiply 2 numbers with the same sign, the answer is always, always, always going to be positive. That means if you multiply 2 positive numbers, the answer is positive. That's something you already knew, right? 2 times 3 is 6. It's all positive. But it also means if you multiply 2 numbers that are both negative, the answer is positive. The other rule we have is when you multiply 2 numbers with different signs, you might be able to guess this one, the answer is going to be negative. By different signs, we mean if you're multiplying 1 positive and 1 negative, that answer is going to be a negative answer. So keeping these 2 rules in mind, we have got a couple problems we're going to look at. I'll do these first 5 together with you, and then you'll try these last 3 for me. Looking at the first one, we've got -3 times -5 equals what? One of the things you can do is just focus in on the numbers and do the math with the numbers first. So if I see this, I might say to myself, well, I know 3 times 5 is 15, and then afterwards I would look at the signs. We've got a negative times a negative. They're both negative. The signs are the same. That means my answer is positive. With positive numbers, one of the things I noticed in that last unit is some people were writing a plus sign to show that it's positive. If we're just talking about 15 like this, you don't need a plus sign in front. If I don't have anything in front, that's how we know it's positive. You don't need to write a plus sign. And that would be our answer. So not too bad. The next one, we've got 4 times -6. Well, looking at that, I would go ahead and I would say, well, 4 times 6. I know 4 times 6 is 24. And then I see I've got a +4 and a -6. Those are different signs. So different signs means my answer is negative. Would give me -24. Our next one, we've got 8 times 8. Well, 8 times 8, that's something you already knew. If you were trying to use your rules, they're both positive, so our answer is positive. 8 times 8 is 64. If any of these multiplication problems are one you don't know how to do, or I should say you just don't immediately know, you can always go back to what we said about multiplication being repeated addition. So if I didn't know what 8 times 8 is, I could start off with something I do know. So maybe you do know 8 times 5 is 40. And then just keep adding more 8s in until you have 8 of them. So this is 5 of them. If I add another one, that means this is 8 times 6. If I add another one, that means this is 8 times 7. And then if I add another one, then I finally get 8 times 8. You can just keep adding in that and use that idea of repeated addition. Continuing on, speaking of multiplication problems you don't know immediately, this next one says negative 7 times 24. I will tell you as a math teacher, I don't immediately know what 7 times 24 is. So that might be one, I'll put it over here. That might be one that we want to do off to the side by hand. If we do that, you multiply your 4 and your 7 first, which gives you 28. And then you multiply your 2 and your 7, which gives you 14. And then add in that to get your 168. So I can go ahead and write 168 for my answer. Now, one of the things I notice in class is lots of times when you might have to do some math off to the side, sometimes students will forget to check the sign. Don't forget, you still want to check and see should our answer be positive or negative. Here they are different signs, so I'm going to go with a negative answer. We've got one last one, negative 95 times negative 1. Well, I could stack 95 times 1 on top of each other, but there is a fun fact that says anytime you're multiplying a number by 1, it's just going to equal that number. So 95 times 1 just gives me 95. What do you think about the sign? Should our answer be positive or negative? Well, they're both negative. They're the same sign. That means I'll have a positive final answer. So my final answer is just going to say exactly what it says, 95. All right. I'm going to go ahead and have you try these 3 practice problems. Go ahead and try number 6, negative 5 times 5. Number 7, negative 3 times negative 7. And then number 8, negative 104 times 0. All right. Well, over here, negative 5 times 5. 5 times 5 is 25, and different signs means negative. Negative 3 times negative 7. 3 times 7 is 21, and same signs means positive. For this last one, negative 104 times 0. Anytime you are multiplying something by 0, it gives you 0. Now, lots of times when I do this in class with students look at it and they say, I see one negative sign. So just like here, one negative sign means negative. They try to write this. They try to write negative 0. When you think about that number line we saw in our previous lesson on integers, 0 right there in the middle is just 0. There's no negative 0. 0 is 0. If you get an answer of 0, there shouldn't be any sort of sign there because 0 actually does not have a sign. It's not positive. It's not negative. The word we use for 0 is neutral. Neutral means it has no sign. 0 is also the only number we have that is neutral. Everything else is either positive or negative. So these right here are 8 examples of what multiplying integers look like. Now we said in this lesson we're going to talk about multiplying and dividing integers. These are multiplying. The next part is going to be on dividing. And there is great news. That news is the rules for division are the same as multiplication. So those rules we looked at the beginning of this lesson for multiplication will also apply to division problems. So you could probably tell me then, when you divide 2 numbers with same signs, the answer is, if they're the same sign, the answer is positive. And when you divide 2 numbers with different signs, the answer is negative. Different signs with a division problem will give you a negative answer. So using those 2 rules, again, we've got some examples we'll look at. Over here, the first one we've got is negative 30 divided by 5. Just like before, the strategy I would recommend is go ahead and do the math first with the numbers and then check your sign afterwards. So 30 divided by 5, well, I know 5 goes into 36 times. So that means 30 divided by 5 equals 6. You could also use that multiplication fact. If you know 5 times 6 is 30, then you also know 30 divided by 5. So we get our 6 there, and then I see the signs are different. That would give me a negative answer. Continuing on, 16 divided by negative 4. Well, I know 16 divided by 4 is 4 because I know 4 times 4 equals 16. So I'm using that multiplication fact. Again, if I check my signs, I've got different signs here, so that would give me a negative. Our next one, 18 divided by 2. Well, this is a fact you already knew how to do. This is something we looked at on Tuesday, right? 18 divided by 2. Well, I know 2 goes into 18 9 times. I don't have to worry about a sign because everything's positive. Our next one, negative 8 times 3 equals, well, sometimes for this one, students are still thinking division, and so they think this is a division problem. Look, I switched it to multiplication, so I'm going to switch my brain and say, well, 8 times 3 I know is 24. But even though we changed the type of math we're using, the idea is the same. The signs are different. Different signs means negative. There's one last one. I've got negative 138 divided by negative 3. Now this is one, the numbers have gotten a lot larger. I don't automatically know how many 3's go into 138. So this is an example of where we might need to use some long division. So I'm going to take my 138 and divide it by 3. Now when I do that, 3 goes into 1 no times because 3 does not go into 1. But 3 does go into 13, so I'm going to combine these numbers together. 3 goes into 13 4 times. I know that because I know 3 times 4 is 12, and that's going to mean that there's a remainder of 1. We can keep going. The next step, bring down that 8 to put here, and then we ask ourselves, how many times does 3 go into 18? Why don't you go ahead, finish up this division, and give an answer for this question here of negative 138 divided by negative 3. Well, if I finish up our division, 3 goes into 18 6 times. 6 times 3 is 18. That tells me that the remainder is 0, or there is no remainder. So we get 46 for our answer. Did you check your signs? I hope so. Here we've got 2 negatives. When you're dividing and the signs are the same, that means your answer is positive. So we get our answer of positive 46. Usually students like these a lot more than adding and subtracting. I hope you feel the same way at home. Go ahead and try these 3 problems here for me. All right, the first one, 5 divided by 5. Anytime you're dividing the same number, it equals 1. And since we have different signs, it would be negative. For negative 42 divided by negative 7, I know 7 times 6 equals 42. So that would tell me the 6. And then the same signs means that our answer is going to be positive. This last one here, I do not know off the top of my head how many 4's go into 136. So I would want to use some long division. Kind of similar to what we had before. 4 does not go into 1, so I'm going to have to ask myself how many 4's go into 13, which would be 3. 3 times 4 is 12, which means the remainder is 1. I can bring down my 6 and divide again. 4 goes into 16 4 times, so we get 34. But that is not my final answer. Why not? Well, we have different signs here. Different signs with division means negative. So we get negative 34. So that's multiplying and dividing integers. Those are the rules. They're not, I think, as crazy as adding and subtracting rules, in my opinion. Maybe you feel differently. But I like them because I think they're more straightforward, right? It's always positive or always negative. Now, one of the reasons it can get confusing is because with adding and subtracting, we were talking about like looking at the larger number. But notice over here our larger number was negative, here our larger number was positive. It didn't matter. So when it comes to multiplying and dividing, we don't care which number is larger. We're simply looking at the combination. If they are different signs, it is always, 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 always negative. And if they are the same sign, it is always, always, always positive. So that's what I mean by the rules being more straightforward. It's also what I was talking about earlier when I said the next thing we're going to look at in this class is going to be doing all 4 of them together. Now, when it comes to multiplication and division, we were looking at multiplication and division problems that were written using these two signs that like cross for multiplication and then the line with the two dots for division. But the further you get in math classes, the less and less you use these two symbols. Instead, you see them written a lot more of the time like these over here. Maybe this looks familiar to you, maybe it doesn't. Either way, it's okay because we're going to review what these things mean now. The first one is what it means when you see a fraction sign. So if I wanted to write a problem like this or like this, that fraction sign means the same thing as division. So both of these problems are saying -4 divided by 2. -4 divided by 2. Both of those mean the same thing as -4 divided by 2, which for fun equals -2. You're probably at home saying, that's not my idea of fun. So the first thing we've got is this fraction line. I can give you a problem written with that fraction line, and you need to know that means divide. Now the next thing we have are parentheses. We saw parentheses a little bit in the adding and subtracting integer lesson. I want to emphasize here that those two parentheses here are right next to each other. There is no plus or minus sign between them. And then over here, similar idea, that 3 is right next to the parentheses, no sign in between the number and the parentheses. So when you have two numbers right next to each other in parentheses, or you've got a number right next to a parenthesis, that is the same thing as multiplication. Both of those problems over there mean -3 times -5, which for fun equals 15. Positive because they're both the numbers are negative. So that's our second thing, is we need to know what those parentheses mean. The last one we've got is this little dot right here. Notice that's not a decimal. It's not -6.7. If it's a decimal point we're trying to use, it would be at the bottom of the numbers. This one's like kind of in the middle of them. What does that little dot there mean? It is the same thing as multiplication as well. So that problem over there is saying the same thing as -6 times 7, which for fun equals -42. So the rules are still going to be the same as what we were doing a moment ago. The new part to this is just the different ways you can see them written. And like I said, we really want to learn this because the further in math you go, the less you use this multiplication and division sign, and the more you see it written with fractions or parentheses or that little multiplication dot. So keeping all that in mind, I've got 3 practice problems for you here. I'm not going to read them out yet, just because part of this is, do you know what they say? So go ahead, try these 3. All right, this first one is saying -24 divided by 4, which would be -6. This next one with the parentheses is saying -8 times 5, which would be -40. And then this last one with the little dot is saying -10 times 5, which would be -50. How'd you do? Now this is it for multiplication and division problems with integers. The one last thing we want to look at is our favorite, some word problems. Before we look at any word problems, I want to do the same thing we did when we started with addition and subtraction word problems. Just want to pause and see what words do you already know that mean multiplication and division. We already were looking at some multiplication and division word problems yesterday, so see if you can remember any words from those lessons to help you with what we're doing today. Well, for multiplication, the word I hear a lot when we're in class is, of course, times, since that's how you read the multiplication sign, but also this word of repeat or repeated, which just comes from the fact that we said multiplication is repeated addition. So either using the word repeated or this idea of something repeating again and again is a clue that it's going to be multiplication. For division, the words I hear the most in class, again, is usually someone says like divide or divided by, but also these words like split or split up, share or share equally. Those come from our definition of division, right? We said yesterday that division is this idea of equally sharing something, but like splitting or dividing up or breaking up into groups, something like that, also is just another way to say I'm dividing something up. There are definitely more words than this, so you might have some other correct words. I am intentionally not putting them all here because there's some words we're about to see in our examples. If you are copying this down in your notes, which you should do, but if you're doing that, there's going to be some words in our examples that you can go ahead and add to this table, so leave some space here for a couple extra words. Now that we've got your brain thinking about some of this vocabulary, so the last part of this is looking at some word problems. The first two examples we're looking at, we did something similar to this with our addition and subtraction word problems. It's kind of just like a math equation written with words. So this first one here says the product of -9 and 3 is what? I noticed in the directions, it says represent each problem with a math equation and answer the question. We want to make sure we're doing both things. Always check those directions. So I want to make sure I write my equation first. In order to write the equation for this problem, there's a word here I need to know, and that word is product. Do you know what product means? Product is the name of an answer when you are multiplying. So if I say 5 times 2 is 10, 10, the answer to a multiplication problem, we call the product. So this is a clue that my equation needs to show multiplication. Now you can write the multiplication problem like we probably all normally would, right, with that multiplication sign. Or you could try using one of these new ways we learned. You could write -9 times 3 with the parentheses. You could use that multiplication dot there. I encourage you in these next couple examples, try using one of those new ways. Just the more you use it, the better you'll remember it. Either way, we are going to have -9 times 3 written on our paper. What is -9 times 3? Well, 9 times 3 is 27. And then there are different signs, so my answer would be negative. So we get -27 for our answer. Number 28 says what is this word is pronounced quotient. What is the quotient of -100 and -20? I see another vocabulary word. That word is quotient. Do you know what quotient means? Quotient means divide. Similar to product, quotient is the name of the answer in a division problem. So right here, we've got 2 more words you can add to that table from a moment ago because these are words you want to make sure you know. Now that we know quotient is division, we can go ahead and do the first part, which is write our equation. You can write it -100 divided by -20. You could also write -100 divided by -20 as a fraction, since we just learned fractions can mean division. Either way you do it, it's going to say -100 divided by -20. Do you know what that equals? You could use long division to do this division problem, but sometimes it helps people to think about money. How many $20 bills do you need to have $100? Well, 20, 40, 60, 80, 100, 5. So my final answer would be 5. I hope you can still see this. What about our sign? Well, they're both negative. That means my answer would be positive. So I'm left with a positive 5. 5 is the quotient. Like I said, those first 2 problems there are kind of just like math equations written with words. These last 2 are actual word problems, like story problems. So for number 29, we've got in Alaska, the temperature dropped 3 degrees per hour for 9 hours straight. What is the total temperature change? Again, I want to get an equation for myself to help me do this math. What are they telling me? Well, they're telling me the temperature is dropping 3 degrees. Now I've put dropped 3 degrees in the box because that is important information. The fact that it's dropping 3 degrees tells me that 3 right there, if I want to represent that change, if I want to represent that it's dropping, that means I need a -3. If I wrote +3, that's going to represent that the temperature is going up, not dropping. So we've got our -3. It's telling me it's dropping 3 degrees every hour, per hour, for 9 hours straight. So that first hour it dropped 3 degrees, the second hour it dropped 3 degrees, the third hour it dropped 3 degrees, fourth hour, 3 degrees. You see what's happening here, right? It's repeated change. Every hour it is doing this. So I could do what I started to do, right? I could write -3, -3, -3, -3 for all the different hours, or I could use multiplication. I could say it's dropping 3 degrees per hour times those 9 hours. So we could write something like this, -3 times 9. What is the total temperature change? Well, what is -3 times 9? 3 times 9 is 27. Different signs mean it's negative. So that total temperature change, I want to represent as -27 degrees. That negative sign there is important because that negative is showing me that it's temperature dropping. I do really want to quickly point out too, look at this problem and this problem. It's almost the same problem, except down here the negative sign was on the 3. Up here the negative sign was on the 9. Did it matter when we did the math? No. Both of them equaled -27. It doesn't matter where that negative sign is for multiplication and division problems. As long as they are different signs, your answer is going to be negative. We've got one last one, number 30, which says Martin lost $240 over the past 20 weeks playing the lottery. How much money on average does he lose each week? Again, we've got Martin has lost $240 over 20 weeks. The question, remember, it helps to focus in on the question. The question is, how much money on average does he lose? I don't know why I stopped circling. Does he lose each week? Go ahead and try to represent this with an equation. All right. Well, here, the key word here is average. And if you have not already, this is another word I would want to add to that table we had. When you are calculating the average is going to tell us about how much he loses each week or after 1 week. So we know he lost this much after 20 weeks. I don't want to know 20 weeks, I just want to know 1. Average is the clue that we are going to be dividing in our equation. I want to divide the money he lost by how many weeks it took him to lose it. Now the other thing, notice I put lost in that box with the 240. Again, that's money lost. The word lost is telling us it's going to be negative. I want to do -240 divided by our 20 weeks. Notice I'm using that division line, or that fraction line to show division. So we get -240 divided by 20. Well, when you divide that out, what do you get? It's going to give you -12. Now, what does -12 represent? Well, it represents the money every week. It's negative to show that it's money he's losing. So the question is, how much money on average does he lose each week? This is telling me he's losing $12 every week. So these are our 4 examples we've got. There is 2 problems for you to try. Let me clean this all up real quick. All right. The first one says the quotient of -42 and 7 is what? The second one says Jerica's apartment automatically withdraws $425 each month for her rent payment. What is the total amount withdrawn after a year? Represent it with an integer. All right, that is everything we've got for today. Thank you so much for watching this video. Hopefully you're feeling a little more confident when it comes to multiplying and dividing integers. And like I said, the next thing that we're going to be doing, the first day next week anyway, is going to be looking at how you do all of this and adding in subtracting integers all at once. So it'll be a good review day for anyone who's not feeling as confident yet on integers. Thanks so much for watching. Bye.